Hello everyone, REM here, and welcome back to another Draw and Discuss. Today we are going to be talking about the punk rock phase of sharks, which, as crazy as it sounds, kind of actually happened. Now, whether you have experienced it already or not, everyone is going to have some time in their life where they see an old picture of themselves and they go, "Who on earth is that? Because that can't possibly be me." Maybe you look in an old yearbook or an old picture from a family reunion and you had bangs, or you were going through a bit of an emo phase, or you were really into layering a lot of necklaces. A lot of times we look back on ourselves and go, "Ooh, what was I thinking? That is not very cool." Sharks, on the other hand, do not have this problem. They can look back at their lineage and go, "Man, I really have been cool this entire time," which is pretty insane considering how far back that yearbook goes. That's because sharks are very, very, very old, one of the oldest living lineages left on Earth today. The earliest record of a shark species goes back about 450 million years, which is already a crazy number in itself, but it gets even crazier when you compare it to something else. Sharks are actually older than trees are. The earliest tree species has been pinpointed to about 350 million years ago, meaning sharks are 100 million years older than the very first trees. Sharks are truly an ancient family of animals, and they are very resilient. They've actually survived 5 mass extinctions, including one of the biggest Earth has ever experienced, which wiped out around 96% of all marine life. But not the sharks. Now, studying ancient sharks is really difficult because they are a cartilaginous fish, meaning that they don't really have bones or bony structures. Their skeleton is made out of cartilage, just like your nose and ears, and that does not fossilize. So the only remains we can find from ancient sharks come in the form of their teeth left behind, which are more calcified and easier able to fossilize, or imprints left in ancient sediment. These teeth, jaws, and occasionally imprints left in ancient sediment have shown us a lot about ancient sharks, and some of them were very strange. So let's look at 2 of those today, the Helicoprion and the Edestus. The first, most obvious thing to notice about Helicoprion is its jaw. I'm going to go ahead and throw up a picture on the screen about what fossilizations and indentations of its teeth looked like. This insane tooth and jaw structure is called a tooth whorl, and it used to be considered that this whorl would be translated quite literally onto the physiology of the shark. I will put up an image for what I mean. The jaw would literally spiral out and teeth would exist the entire way down. However, as awesome and strange as this is, it's not really the main theory for what they look like nowadays, as having a jaw like that really wouldn't provide any benefit to the animal that scientists could find, but they could find a benefit if the jaw looked a little bit different than what you would immediately assume from seeing these indentations. The current leading theory is that instead of a jaw that continued all the way down into a spiral with teeth all the way down, which seems rather inconvenient and hard to work around, rather, Helicoprion likely had a circular saw-type jaw. By this, I mean that the lower jaw had a half-circle ridge that had teeth on it, like you would see on a circular saw, and the rest of that tooth whorl was hidden inside the jaw, and unlike how modern sharks operate, where they lose teeth and the rows behind them push forward and replace those teeth, this tooth whorl would rather move and the teeth would be replaced and grown that way. This is still really weird, and like I mentioned, most cartilaginous fish, like sharks, are hard to study from the past because the rest of the animal does not fossilize, so you have to hope that there might be a body imprint somewhere, but those are, again, very rare. So we might never fully understand how this shark looked and why it looked like that. I personally align with the circular saw type description because it seems just a little bit more useful and realistic. If you think about a jaw that spirals down with teeth all the way to the end, what is that helping this animal eat? I'm really not sure. If anything, it seems like that would be kind of a hindrance. But if you look at it as a circular saw, now you have a single structure that can put a lot of pressure on prey because of the low surface area, which could have been very helpful for cracking open hard-bodied animals or cleaving soft-bodied animals right in half. But I'd love to know what you think. If Helicoprion actually did look like the original interpretation, based literally on these teeth impressions, with the long jaw with teeth all the way down, what sort of advantage do you think that would give them in the wild? What would they be eating? How would those teeth be naturally selected for in the gene pool? It's really interesting to think about, and I'd love to hear everyone's ideas. On the bottom there is our second star of the day, Edestus, whose name comes from the Greek word edeste, which means to devour, which seems pretty accurate. Like Helicoprion, which is actually a pretty close relative, Edestus had tooth whorls, and they had one on the top jaw and one on the bottom jaw, meeting right in the middle. This leads Edestus to sometimes be called the scissor-toothed shark, because instead of having a row of teeth that went all the way around the edge like you would see in humans and most other animals with teeth, it just had one line right in the middle of the gums. This makes me deeply uncomfortable for some reason. The idea of having teeth only in the middle of your palate, front to back, top and bottom, meeting in the middle, I do not like that at all. This is really creepy, and if this were still alive today, I would be afraid of it. Now, Helicoprion and Edestus have jaw structures and teeth that are not seen in any modern shark species, and this is likely in part because both of these animals are shark adjacent. They are in the shark family. They would be at the family reunion, but they are not in the same lineage of sharks that we would see today. Both of these animals are considered eugeniodontid fish, which are also cartilaginous fish. What on earth does that even mean? Well, eugeniodontid refers to the tooth whorls and strange jaw structures found in all of these fish, and like mentioned previously, cartilaginous just means they don't have bones or bony structures. Their internal structures are made from cartilage. Now, this not only contributes to the difficulty in determining what these sharks looked like, but also linking them to modern-day sharks. Despite the confusion about where these fish might end up in the shark family tree, it's pretty obvious that sharks have been cool for as long as they have been around, which is not something that every species can claim. If you consider other famous marine animals, like whales, who obviously are mammals and not fish, so not directly comparable, but similar, whales actually came from land-based pig and dog-like animals, and don't worry, that is going to be an episode all on its own because it is crazy. But if I were a whale, I would want to ignore that part of my past, pretend that that photo in the yearbook maybe wasn't there when my family used to be a tiny dog, and now have evolved into some of the largest animals on Earth. Sharks, though, sharks have always been awesome, and they've been awesome for longer than there have been most of the species on Earth today. So, just like these sharks are showing us here, always remember to smile.